or upload it if it's too long. I think I'll stop it and do little sections. So anyways, for those of you who are watching this wherever, the oxidation state for Mn atom. So again, atom means it's a neutral substance. So atoms are 0, +7, +4, and +3. Those are all on the reference tables. I'm not sure if that can see that there, but these are all the charges on the reference table. These are for ions, not an atom. Atoms are neutral, so it's a 0. Hey, Leah. Did you do your homework? Okay. All right. So Leah, we just talked about 22. A little bit here about how atoms are neutral, so it's number 1. 21. This is something I stress, but I don't necessarily give you notes on. It's just something we talk about over and over and over again. So in order for this battery to produce electricity, what has to be transferred? Electrons. That's what it's all about. Okay? Leo Ger. Lose electrons, oxidize. Gain electrons, reduce. So redox stands for? What does redox stand for? Oh boy, the heat's already gone to your brain and melted it?
Yeah.
You're learning about electrochemistry. I just said the little phrase you need to memorize. Lose electrons, oxidize, gain electrons, reduce. Leo Ger, memorize that. So what's redox stand for? Yes, it means reduce and oxidation, or reduction and oxidation. That's what redox means. So when you see that word, you need to think electrons, transfer of electrons. Whoever is reduced gains, right? Picks up the electron. Whoever's oxidized gets rid of the electron. Okay? Electrons going back and forth between atoms and ions, that's what creates electricity in batteries, for example. Okay? So electrons are the key to this whole unit. And that's where charges come from, losing, gaining electrons. All right, let's go over the homework. All right. Let me first give you credit. You talking about your picture? Yeah. Yeah, some pictures are funny because it's when you guys were like little. And some have updated, some have not. Like, for some reason, some are like when they were in 7th grade. I don't know why that is.
Someone surprised me. Oh, take the
I don't have you guys.
It's really funny.
Mine's from this year, I think.
Yeah, some are updated, some are not. I don't really look at them, so I don't know. Only when I click on the transcript.
I only know because I go to school.
Yeah, you're
What are we doing in lab?
finishing those 3 worksheets and doing the esters as a demo.
Are we done with those?
I don't
What
think
about
you're done.
tomorrow lab?
Are they new? Are they new 3
I
words?
explained it yesterday.
Well, don't give me sass.
What did I say? What did I say?
I don't know. I wasn't
You're working on those 3 worksheets.
Sometimes you just go on.
Then you're going to hand in the 3 worksheets, and then you're going to be given this acid-base review packet due next Friday, and you're going to work on that individually. It's going to be a fun day. All right, so Nicole's not here.
It's gonna be hot here.
And he said,
Matt's not here. Ariel's not here. Courtney should be here. I'm going to say that on camera. Courtney, you should be here. She's not on the field trip. And Watson. All right, here we go. So the homework.
It was 2 labs ago.
Let's go over.
Because we did this.
Hannah, can you? I know you don't want to sit down. Can you sit down?
I have my worksheet.
Yeah, I know, but I just want you to sit down. I don't know. I just like being uniform. That's all. All right. Here we go. So I did the first one with you, correct?
Well, you balanced it.
But I didn't do the half reactions.
No.
Okay. So let's do the half reactions for that first reaction. So we should have a 2 in front of the Ag plus and a 2 in front of the Ag 0.
Yes.
Okay. So your oxidation. So let's do this. All right. So I'm gonna go slow because people aren't here, and you know, we don't need to really get onto a whole lot of new stuff. Plus, it's good to do this slowly. You guys need to be able to, before we're done with this topic, so by the end of next week, be able to look at a reaction. I actually would hope you would be able to do it by the end of today. Look at a reaction and tell me who's oxidized, who's reduced. Okay, so Leo Ger, lose electrons, oxidize, gain electrons, reduce. Keep saying that, and that's going to help. So if you look at the copper, it goes from a 0 to a +2. So copper is oxidized, but you need to put that 0. If you don't put the 0, you can't get credit. no matter how much I argue with the teacher who's going to be grading your reagents, if you don't put that 0, I can't say in good conscience and, you know, feel good about it. I can't say, yeah, Tyler knows it's copper 0, but he just wrote copper because he forgot. I can't, that's basically cheating. I don't know if you don't write this, you may mean this. That is not oxidized. That's not oxidized. So if you just write Cu without a charge, even if it's a 0, then the teacher has to assume you don't know which copper it is. It's always a reactant. Your products are never oxidized or reduced. They are the result of the oxidation and reduction. So these here are going to be oxidized or reduced. Never the products. Never, ever, ever the products. So if that's a reactant, you got to tell me it's a reactant, which is 0, not +2. Okay, I say this all the time, every year. Still, there's always a few that refuse to label the charge. It's not because they're refusing, it's because they forget. But you got to be good about that, all right? So anyways, copper is going from 0 to +2. Why? It's getting rid of 2 negative charges. So copper's losing, Leo, lose electrons, oxidized. So copper is giving electrons to Ag+. So Ag+ is gaining electrons. That's the GER. How do I know? Because Ag+ is turning into Ag0. +1 down to a 0 is reducing. That's reduction. How does it reduce? It gains negative charges that cancel out the positives. So that's gaining electrons. I would say that is more important by far than half reactions. If you can't write half reactions, and you might have to on the reagents, so I'm not saying it's not important, but if you can look at a reaction and tell me which reactant is oxidized, which reactant is reduced, most questions that will get you through, or you'll have at least a pretty good chance of getting them right. So that's the most important skill here, okay? This part, the half reactions, yeah, you might have to write them. Sometimes they're on there. But if you can't do this, then you have no shot at doing this, right? So here we go, half reactions. The oxidation half reaction, Cu0, reduction, Ag+. Yields, Cu +2, and it loses 2 electrons. Some students pick this up pretty quick. I'm just going to tell you, whatever the positive charge is, that's how many electrons there are. It has to be the same. Because if this is becoming +2, the only way it got that way is getting rid of 2 negatives. So if this was +6, then that would be 6 electrons. If this was +1, it would be 1 electron. That's the little trick that some kids pick up pretty quick. So you don't even really need to think about it. You just see what's the total positive charge, and then the electrons have to cancel that out. So it has to be the same number. So if copper, oh sorry, this is 2 Ag+, right, from the balanced equation. If copper is losing 2, silver has to gain 2. Electrons that are lost are always, so think about a battery. This thing is sealed. Electrons aren't getting in or out. So whatever's happening in here, something is losing electrons, whether it's losing 2 electrons or 1,000. However many electrons are being lost, something in the battery is gaining those electrons. It's not getting out, okay? So that's, you know, to help you understand there. Whatever this loses, this gains. Has to be the same. Conservation of charge. So this now becomes 2Ag0. Though that's the half reaction for number 1 then, the first one. Questions? I'm going to go nice and slow. We're going to go through half reactions of all of them. Okay, I'm probably going to spend the next 15 minutes at least going through the homework. Then I'll go through A on the homework due Monday. And then if time, I'll show you I want to show you a redox reaction. I think it's just what we good for you to see it. All right? I'm not too concerned about getting notes done today. So, pay attention, ask me questions if you need to. I know sometimes this is really boring, just listen to me going over homework, but it's important. You got to know how to do this. All right. Here we go. Second one. So I'll write the overall equation. Al plus Cu plus 2 yields Al plus 3 plus Cu. Okay, who can balance it? Come on.
2Al solid.
2Al.
3Cu.
3Cu.
2Al and then 3Cu.
Very good. Now this is a solid. This is aqueous. Aqueous solid. Now I'm going to just explain that. So what's the charge on aluminum solid? 0. Elements as solids, liquids, and gases are always 0. You need to remember that. So 0 and 0. These are aqueous, so they're ions. The reason he put a 3 here is because that's a +6. He put a 2 here because that's a +6. Conservation of charge. Charge is balanced. If there's 3 here, I need 3 here. 3 coppers, 3 coppers. 2 aluminums, 2 aluminums. Balance your charge first. Hold on, I got through something happening. Need water. Yeah, I'm getting better, but coughed up some nastiness this morning. Just in case you want to know. All right,
That's
so one time my friend was sick, and he coughed up this huge phlegm wad.
I've done that before.
But I don't know if I was living with him at the time or whatever, but I was like, everything all right? He's like, yeah, it was so big it smiled at me going down the drain. I thought that was funny. And disgusting. That you could have phlegm that's alive in your body. Anyways, back to this. 6 and 6. So balance the charge first. So +6, balance with a +6. That charge is conserved. Then go back and balance the mass with the atoms. All right? So I would say the 2 most important things about going over this, can you balance and can you tell me who's oxidized and reduced? If you can do those 2 things, you're in pretty good shape. Half reactions, we're going to be practicing all next week with the different cells we're going to learn about. So I would say that's not as important right now, but by the end of next week it is. All right, so here we go. Who's oxidized? Who's reduced? Al what? Al0 is oxidized. Very good. Cu+2 is reduced. Very good. Why don't we take a look-see at table J? Table J, as in jerk.
I'm trying to get it right. I think it's SpongeBob. So
I don't know what that is. Or jackalope.
Cantaloupe.
Yeah.
Doesn't start with a J.
No.
All right, go to table J.
I'll say 2. He'll be like,
Now.
that's not good for me.
Cantaloupe, it can be.
It's not good for you, or it is good?
No, it can be.
I'll send you a
It can be
link.
what?
Good for
Oh my
you.
God.
How?
It's scary.
What do you
It's a
mean how?
fruit.
It's a
Is it-
fruit.
Should it always
All-
be good for
Almost
you?
all fruits good
But
for
it
you.
can be. What do you mean? So like
It couldn't be good
We'll
for
talk later. I gotta move on here. If you want to talk about cantaloupe in lab, we can do
I
that.
just
All
want
right.
cantaloupe.
Now,
you? Yeah, me too.
look up aluminum, look up copper. Look up aluminum, look up copper. Or find aluminum, find copper on table J. Actually, let's do this. Find copper, silver, and aluminum.
Copper, silver, aluminum.
All right, who's the highest one up?
Aluminum.
Al. Who's next?
Copper.
And it's like way down, right?
Yeah.
And then zinc's underneath it.
What?
No.
No.
You said silver.
Plus zinc's above copper, isn't it?
Yeah.
So AG's at the very bottom, isn't it?
No.
No,
right
AU's
after.
bottom.
All right, I'm losing my mind. So it goes. Hold on. Is it zinc, copper, silver, gold?
Wait.
Yeah.
Yes, it is.
No.
No.
Yeah.
No. Zinc is like
above
7 up.
Zinc is like.
But no, but zinc's above copper.
Yeah.
And then the last 3 are copper, silver, gold.
Yeah.
Okay.
Right on camera.
No, I don't think that was.
No.
Don't patronize me,
I
Tyler.
was just showing your stuff, you know.
I was worth it to me.
Was it really?
Yeah.
I feel like that was real anger.
No, that wasn't.
You've
No.
seen real anger.
Yeah,
that was
no.
not real
Yeah,
anger.
no, when
Yeah,
you get to
I
five,
I was pretty mad at Mayfield.
That was very.
Oh, that.
That
Andrew.
too.
Listen, that
Fuck.
was as mad as I've been in years. All right,
When
back
you
to this.
literally cornered him.
Back to this. That was not intentional. All right, it just happened to be where he was standing. All right, back to this now. Aluminum 0, copper +2. If you don't label the 0 and the +2, again, I get tired of saying it, but I need to say it. You will lose points. You can't just put AL and CU. You need to specify these 2. Okay. All right, here we go. Half reactions now. I'll come back to table J in a second. There's a point to that. All right. Who's got this? Morgan Heath, thanks for volunteering. AL0 yields. Oh, sorry, 2AL0. Very good. Close. 6. You were adding, we gotta multiply. 2 times 3 is 6, so if this is +6, this is -6, adds up to 0, balances out with a 0. So, I know you might be fixing things. When you're done, look up here. 2 aluminum. Each of them lose 3 electrons. They each get rid of 3 electrons. So you have 2 Al plus 3s, and that adds up to 6 electrons lost. Exothermic, right? It's not exothermic, but I want to use that term to help you understand it's on the right. It's lost, it's on the right. Same exact concept. Release electrons, it's on the right. If aluminum loses 6, Cu plus 2, how many do we have? 3 of them. Gains 6 electrons. 6 negatives, 6 positives adds up to 0, yields 2 Cu0. Oh, 3, sorry. 3 Cu0. Those are your 2 half reactions for that. Okay, so there's the first 2. Why'd I have you go to table J? Who's oxidized in the first reaction?
C.
No. Yes, I'm sorry. Cu. Who's oxidized in the second reaction?
Al.
Al. Okay, look up here. In the first reaction, what are the 2 metal species reacting? The first reaction, you have Cu and Ag+, right?
Yeah.
Okay, so look up here. Here's Cu, here's Ag. Second reaction. Who's reacting? Aluminum and copper. Look up here. Here's aluminum, here's copper. So out of these 2, this one is oxidized, this one's reduced. Out of these 2, this one is oxidized, this one is reduced. What do you notice? If they're higher up on table J,
Oxidized.
they're oxidized. I know I ask you to remember a lot of things. That's another thing I'm asking you to memorize. The higher on the chart, the more reactive the metal is. If you look at the first 4 on table J, top 4, they're all in group 1 or group 2. They are the most reactive metals. Metals like to be oxidized. Why? Let's think of Na. Na is 281. Leo, Ger, lose electrons oxidized. If sodium loses that 1 electron, why is that good? Stable. Right, Aaliyah and Morgan, you with me? You gotta look up here. If Na, so let me write it so you guys can see it. Yeah, I'm trying to connect what you've previously learned to new stuff because that helps you actually learn better. So you've learned Na likes to lose that when it forms bonds because it forms Na plus 1, which is a complete octet. So I'm comparing this to the Leo oxidizing, lose electrons oxidized. Metals really like to lose electrons. Well, what if you're reacting 2 metals together? The more reactive it is, that's the one that wins. So the higher on table J, that's the one that gets to lose electrons. The one that's lower on table J actually is forced to gain electrons. It doesn't want to, but it doesn't have a choice. Think of the one that's higher up is stronger. So it's forcing the weaker metal to take the electrons. So if you react aluminum and copper together, every single time aluminum loses and copper gains. Every time. You cannot fix that. That's called spontaneous. And here that's what's happening. That's how electricity is being produced. Okay? That's what the demo's all about. I take, so zinc is above copper. I take zinc and I put it in copper solution. Then I take copper and put it in zinc solution. Only one of them reacts. The other one just sits there and doesn't do anything. So the reason it doesn't do anything is because it isn't in the right order. We always need the metal that is higher on table J to be the solid and the metal lower to be dissolved in water. That's what this reaction, all these on the homework are showing. Okay? So what am I trying to really get you to understand? The higher up it is, the more it's going to be oxidized. That's important to remember. The lower it is, the more likely it is going to be reduced. So gain electrons. Sometimes, trying to make sure I say this right. Where is Fe in relation to Mg? On table J. Fe should be below Mg.
Yeah, it is.
Yeah. If you have iron pipes in the ground outside your house, maybe with water in them, or maybe lead pipes if they're old enough, okay? Sometimes there is a wire run from the lead pipe or from the iron pipes. Let's say you have a pipe made of iron, all right, and then there's a wire run to like a magnesium block. And the reason for that is the iron pipe, or it could be lead pipe, can oxidize over time. And that will eat away at the pipe, and the pipe might get a hole in it eventually. But if you connect a magnesium block to it, magnesium will oxidize first. So this pipe will be clean and will be nice and new forever as long as you have magnesium attached to it. So why? Table J. Magnesium is higher up, isn't it, than both of those metals? So magnesium will oxidize first, forming magnesium oxide, and this will start to deteriorate over time, but your water pipe will be pristine. It won't have any rust or corrosion, and it'll be fine, because you want the pipe to be, you don't want water leaking out all over the place. So that's just, I've seen that on Regents actually. It's a pretty good real life application to understand the oxidation here. So the higher it is, the more reactive, the easier it is to oxidize. That's why a lot of things we use to build things, iron, zinc, chromium, nickel, a lot of that stuff, if you look on table J, pretty low compared to other metals, right? You don't want to use nails and screws, especially in outdoor buildings and whatever, that are going to just rust or corrode like in a week. That's not going to really work. So you guys heard of galvanized steel or galvanized screws, nails? They're coated with zinc. So you might have a steel nail, but it's coated with zinc. Because isn't zinc below Fe?
Yeah. No, it's above it.
How far?
2 above.
2 above. Okay. I think maybe with that. Now, what was the reasoning for that? Well, the easiest answer is iron rusts. Zinc does not. So zinc can corrode and oxidize. It's not called rust though. But that's usually what galvanized means. This is covered with zinc. It's not very reactive. So maybe that has something to do with water. Maybe Fe reacts better with water than zinc does. But in general, I think you understand what I'm trying to get you to see. The concept here is higher up, easier to oxidize. So I know I spent a little time on that, but every single reaction on the homework, the metal that is more reactive is always oxidized. And that's always going to be true. All right, let's move on. Let me go through and read the answers to the rest of it, because time's flying here. Let me just read the answers to the last 3, and then I'm going to do half reactions for the third one with you. And then we might go to the other sheet just to make sure we have time. So here we go. So the PB plus 2 one. The Li solid to 0, PB solid to 0. You should have a 2 in front of both Li's. A 2 in front of both Li's. That's balanced. Li 0 is oxidized, PB plus 2 is reduced. Li 0, losing electrons, becoming more positive. PB plus 2, gaining electrons, becoming a 0 charge, so it's reducing. Next one, SN 0, Fe plus 2, SN plus 4, plus Fe 0. You should have a 2 in front of both Fe's. SN 0 is oxidized, Fe plus 2 is reduced. Last one, you should have a 2 in front of both CS's. CS 0 is oxidized, Ni plus 2 is reduced. Questions? Now is the time. So if you can't look at these reactions and tell me who's oxidized, who's reduced, next week's going to be hard for you. Okay? So, you know, I will be after school today. All next week I'm available. Should be. Let's do the half reaction for the third reaction. All right. Let's do it on the back of the sheet. Or some, you can put it anywhere you want, really. I'll put it on the board so you don't have to flip it. So you got PB plus 2 plus 2Li 0 yields PB solid plus 2Li plus 1. Oh, I'm sorry. Well, okay. I flipped those, but it doesn't matter. All right, so there's your overall balanced equation. Plus 2 on both sides, and then 2Li, 1 PB. Okay. So again, who's oxidized, who's reduced? Oxidized is the Li 0, reduced is the PB plus 2. You need to label those charges, even if it's a 0. I know 0 isn't a charge, but you have to label it. All right, so the 2 half reactions. I'm actually going to give you a second here. More than a second. A couple minutes. We got some time. A couple minutes here. Try to figure those out on your own. and then we'll go over it. So half reactions for that. Because you were supposed to figure out how many electrons are transferred for each one. So I'll go through that in the last two as well. Yeah, I just looked up what is galvanizing. I knew I wasn't crazy. It's a zinc coating on steel to prevent rusting. But I guess it's just not, consistent with what I was talking about. All right. Yeah, I'm gonna try to leave the window shut today, see if that helps. That means it's gonna get all stinky.
Why you live in here?
At least you guys weren't deodorant. Lab is gonna be real hot.
Lab?
Yeah, by the end of the day, this room gets super hot.
We pulled all the shades down and left the lights off all day.
Well, the lights don't really do anything, but the shades, I don't know, maybe. All right,
Official lighting.
here we go. You guys all, the ones I checked, did a good job. 2 Li0 yields 2 Li plus 1. That means 2 electrons are lost. It loses 2 electrons, becomes positive 2 overall. Each Li loses 1. That means Pb plus 2 gains 2 electrons and forms Pb0. You need to label the zeros and the plus 2s at all times. 2 electrons are transferred. Again, how do you figure out the number of electrons transferred? Look at the positive charge here. Plus 2, I need to lose 2. All right, the next two, just real quick. The total number of electrons lost or gained in the bottom one there, the number of electrons transferred is 4 electrons, and then that's the one with tin and iron. And then the last one with cesium and nickel is 2. 2 electrons are transferred in the bottom. All right, go to the homework due Monday. I'm going to do A with you, and that's going to be it for us today. I'll show you that demo on Monday. Probably better off anyway, so everybody sees it. 5A. 5A here. 2H2 gets to gas. Blah 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 blah. Okay, so I'm going to do A with you because it's complicated. All right. B and C, you're going to do exactly like I do A. You're just going to do it on your own. Okay, so you have 2H2S plus SO3 and yields 3S solid plus H2O, 3H2O. All right, first thing you always do in a redox reaction or a electrochemical reaction here is label all the oxidation numbers, okay? So I'm gonna do this with you. You look it up on the periodic table, but you guys should all know H is plus 1. So I always just go through, label all my H's plus 1. If there's oxygen, I always know that is -2, so I label all my oxygens -2. I feel like those are ones you have memorized already, or we've done it so many times. Sulfur gets a little bit weird, okay? So if you look in the box for sulfur, I think it's -2, +4, and +6. So here and here, it might be 2 different charges. And here, it's labeled solid. What does that mean? 0. All right. Now, if H is +1, and there's 2 of them, Trevor, what does S have to be?
-2.
-2, very good. Now here, a little bit harder math, I suppose. If you have 2 H pluses, that's +2. 3 -2s, that's -6, so S must be +4. Haha. Here's why this is hard. That's why I'm doing it with you. Okay, which species up there does the charge stay the same? So on both sides of the equation, it stays the same. So you have H's, you have S's, and you have O's.
H now.
No. H's, S's, and O's.
Oh.
Which do not change. H does not change, and O doesn't change. Guess what? If the charge doesn't change, it's not losing or gaining electrons. Does that make sense? The charge doesn't change, it's not losing or gaining electrons. So your oxidation half reaction and your reduction, I'm going to do it real quick. This sulfur is going from a -2 to a 0. So is it losing or gaining electrons if it's going from -2 to 0? Losing. That's oxidizing. This sulfur is going from a +4 to a 0. It's gaining electrons. Actually, sorry, that's 2s minus 2. This S +4 is being reduced. It's gaining electrons.